Picture this. It is 2011, and someone is standing in their kitchen trying out this life hack they just read on an early internet forum.
Right.
And, they think they're pulling off this brilliant piece of DIY chemistry, right?
Mm.
Like making a highly potent extract right on their countertop. But what they absolutely do not realize is that an invisible, incredibly heavy gas is just quietly pouring out of their equipment.
Yeah, totally invisible.
Exactly. It is cascading off the counter, pooling onto the linoleum floor, rising at the baseboards, and just creeping silently toward the pilot light of their hot water heater.
And all it takes is a single microscopic spark. That is the exact scenario that played out time and time again.
It really is staggering when you think about it. I mean, if you look at the extraction industry today, you expect absolute sterile precision.
Oh, absolutely.
We all know the modern landscape, right? The sleek hardware, the strict lab testing regulations, the products that look like they were engineered by aerospace technicians.
Mhm.
But when you peel back the curtain on how those highly refined products actually came to be, that pristine laboratory completely vanishes. So, welcome to the Deep Dive. I'm your host, and joining me is our resident extraction history expert.
Glad to be here.
Today, our mission is to explore a really fascinating stack of notes provided by our source, Nug Notes, and it's titled The Volatile Genesis of Butane Honey Oil. We are going to figure out how a highly technical, stringently regulated modern industry was born out of chaotic, highly dangerous backyard chemistry.
Yeah, it's quite a story.
It really is. Okay, let's unpack this because we are not just talking about history here. We are looking at a Wild West tale of early internet forums, desperate shortcuts to gold, and literal house explosions.
What's fascinating here is the massive, almost unbelievable contrast between those slick concentrates you see today and the wildly dangerous foundations that were built upon. I mean, we are talking about an era where the safety manual was essentially written through trial, error, and, well, catastrophic failure.
Right.
To really grasp how the culture got so reckless, we have to travel back to the late 1990s and early 2000s to what is known in the legacy community as the open blast era.
Yeah, and looking through the Nug Notes, we see these early pioneers of the era, figures going by names like HMK and Kenneth from a group called Trichome Technologies.
Yep, the legends at the time.
And they were at the absolute forefront of something called open blasting to extract what they called honey oil. Because before this, extracting resin was incredibly labor-intensive.
Very.
You were dealing with ice water, physical sifting, just massive amounts of manual labor for a relatively modest yield.
Exactly. Traditional hash making is a mechanical process. You are physically breaking the resin glands off the plant material. But what HMK, Kenneth, and others were pioneering was a chemical process, a solvent extraction. It was an absolute paradigm shift.
But the materials they were using for this paradigm shift are what blow my mind.
Oh, yeah, it's wild.
You look at their toolkit, and I mean, you needed a PVC tube from a hardware store, some cans of commercially available butane lighter fluid from a cigar shop, standard coffee filters, a hose clamp, and like a Pyrex baking dish.
That was it.
That was the barrier to entry for chemical extraction.
Yeah.
It sounds less like advanced chemistry and more like a high school science fair project gone rogue, or, trying to strike oil using a shopping list from the local hardware store.
It really does. And you can immediately see why it was so alluring. It bypassed hours and hours of manual labor.
Wait, I am stuck on the physics of this, though. Was it really that simple to just extract this stuff? How did a PVC pipe and a coffee filter not immediately signal to people that this was a terrible idea?
Right.
I mean, butane is highly pressurized inside those commercial cans.
Right.
If you were blasting pressurized gas into a closed PVC pipe filled with dense plant material, wouldn't the pressure just blow the coffee filter clean off the bottom? How is this actually working without immediately rupturing?
That is a great question, and it comes down to understanding phase changes and pressure dynamics. So when you release the butane from the pressurized can into the top of the PVC tube, it is no longer under that extreme pressure.
Okay.
Because the tube isn't perfectly sealed at the bottom, since the coffee filter is porous, the pressure drops rapidly. And when a pressurized gas expands, it undergoes massive, instantaneous cooling.
Oh, so it isn't hitting the coffee filter as a high-pressure blast of gas.
No, not at all. It supercools itself into a freezing cold liquid solvent. This liquid butane then washes down through the plant material, driven by gravity and the continuous flow from the can above.
Got it.
And here is the brilliant, albeit dangerous, chemistry of why they used butane specifically. Butane is an excellent nonpolar solvent.
Okay, let's break down nonpolar for anyone who maybe skipped organic chemistry. Why does that matter here? here?
It matters because of the rule, dissolves like.
Mhm.
The active chemical compounds we're after, the essential oils, the cannabinoids, the terpenes, they are lipids.
Right, fats.
Exactly. They are fat-soluble, meaning they are non-polar. Water is polar, which is why water won't dissolve them. If you used a polar solvent, like certain alcohols, you would end up pulling out all the water-soluble junk inside the plant, like the chlorophyll, making the extract bitter and really dark.
Ah, okay.
But butane, being nonpolar, acts like a highly selective chemical magnet. It effortlessly dissolves the nonpolar oils while completely ignoring the water and the green plant matter.
So this freezing liquid butane strips the oils, drips through the coffee filter, which I guess just acts as a crude particulate screen to keep the plant matter out, and pools into the Pyrex dish below as a liquid mixture of solvent and raw extract.
Precisely. And then comes the evaporation phase. Butane has a remarkably low boiling point, right around 30 degrees Fahrenheit or just below freezing.
Wow, that low.
Yeah, so at standard room temperature, butane is boiling. The theory was that you just leave the Pyrex dish sitting out, and the liquid butane would boil off into the open air as a gas, leaving behind a highly concentrated, potent resin on the glass, the honey oil.
It really was a shortcut to gold. But because the barrier to entry was essentially just a trip to the local hardware store, this technique absolutely refused to stay confined to experts.
Right.
I mean, it didn't stay with trichome technologies, it spread like a virus.
You really have to view this through the lens of early internet culture. Information was suddenly completely decentralized. Platforms like Arrowwood forums and Tokacity became these massive, unregulated digital hubs where people shared, debated, and, well, endlessly tweaked these extraction methods. You had thousands of people acting as amateur chemists, basically peer-reviewing each other's highly volatile experiments in real time.
And reading through the archives in our notes, you see this viral spread birth a whole new glossary of slang. The community moved from honey oil to chasing consistencies they called butter and earwax.
Yeah, butter was huge.
It gave a totally new language to an old obsession. But the reality of this backyard extraction was incredibly messy. Because they were trying to evaporate the butane faster, the notes describe people chasing perfect concentrate slabs by leaving dishes in the direct summer sun, putting them on kitchen stovetops, or literally sitting them on hot car dashboards to bake the gas out.
And the chemical results of that impatience were wildly inconsistent. You had amateur extractors using very rough, sometimes wet starting material, combined with incredibly sloppy technique.
Right.
Maybe they blasted the butane for too long, pulling unwanted waxes. Or maybe they used incredibly cheap canned lighter fluid, which isn't chemically pure. It's full of mystery lubricating oils and sulfur-based odorants so you can smell a leak.
So all of that ends up in the Pyrex dish.
Exactly. They were creating what eventually earned the very descriptive nickname poop soup.
Poop soup.
Yeah.
Which is exactly what it sounds like. It was this dark, harsh, incredibly unstable wax, full of plant waxes, chlorophyll, heavy metals from the cheap cans, and crucially, large amounts of residual chemical solvent.
Yeah, a real mess.
And the physical toll this took on the people consuming it is alarming to read about.
Because inhaling raw hydrocarbons is not something the human body is meant to do.
Right. The sources specifically mention users experiencing what they call dab sweats.
Yeah.
These were intense, brutal physiological reactions, heavy sweating, violent coughing fits, and severe bodily distress right after inhaling. And then there is this deeply unsettling detail about hissing shatter.
Let's talk about the physics of that hissing shatter, because it highlights exactly what was going wrong in this era.
Well, shatter is supposed to be clean, stable, and glass-like, right? But the notes say that early on, a slab of shatter could look completely translucent and perfect to the naked eye. Yet when you held a flame to it, it would literally hiss, pop, and spark. It's like baking a beautiful cake but leaving pockets of raw explosive gas baked right into the center of it.
That's a great way to put it. Think of the raw extract like molten glass. As it sits on that car dashboard and the butane slowly evaporates, the extract cools and increases in viscosity. It hardens into a dense molecular matrix.
Okay, the remaining liquid butane gets physically trapped inside that hardening structure. It is exactly like microscopic bubbles suspended in solid amber. The butane physically cannot escape the dense matrix of the shatter at room temperature.
Wow.
When you finally apply a flame to consume it, those microscopic pockets of highly flammable gas rapidly expand, burst open, and ignite. That is the hissing and sparking.
Jesus.
If we connect this to the bigger picture, The physiological danger here was just immense. You aren't just irritating your lungs, you're inhaling unpurged butane gas, which displaces oxygen in your lungs and deprives the brain of oxygen, while simultaneously introducing industrial hydrocarbons and mystery oils directly into your bloodstream.
Which is terrifying.
Very. The dab sweats and the hissing shatter weren't just quirks of the era. They were massive, flashing red warning signs. They were the earliest biological indicators that the culture was moving far too fast for its own good. They were prioritizing raw potency and yield over basic human safety and chemical purity. But as terrifying as it is to consume a product with explosive gas suspended inside it, the danger wasn't just on the consumption end. Here's where it gets really interesting and incredibly dark. By the early 2010s, the actual process of making this stuff started turning residential neighborhoods into literal disaster zones. The blast wave. As open blasting spread from niche internet forums into mainstream underground practice, people started doing this inside their homes. Bedrooms, garages, kitchens, they were all being turned into makeshift, highly hazardous extraction labs. The sources mention local burn units filling up with severe facial and hand injuries tied directly to this makeshift extraction. But I have to ask, how did thousands of people not realize they were basically filling their kitchens with invisible dynamite? Was there zero awareness of the physics involved? How did they justify doing this indoors?
It goes back to a tragic, widespread misunderstanding of physics. When the average person thinks of a gas or a vapor like smoke from a fire or steam from a kettle, they intuitively expect it to rise. They think, if I crack a kitchen window or if I turn on the stove hood fan, the butane gas will just float up and vent outside.
But butane doesn't do that.
No. The molar mass of butane makes it significantly denser than ambient air. It doesn't float up, it falls.
So it sinks directly to the floor.
Exactly.
Yeah.
Picture someone standing at their kitchen counter blasting tubes of butane into a dish. The gas hits the counter, cascades over the edge like an invisible waterfall, and begins to pool on the floor.
Oh, man.
It spreads out, creating an invisible, highly flammable carpet of vapor. It fills the room from the ground up, millimeter by millimeter. It silently pools around the baseboards, creeps under the kitchen cabinets, and most critically, it flows around household appliances.
Oh, wow. Appliances with automatic motors.
Yes. All it takes is a single, tiny spark, a refrigerator compressor kicking on to keep your groceries cold, the pilot light of a hot water heater in the adjoining garage, a static shock from shuffling across a rug in socks, even just the internal spark of a light switch being flipped.
And boom, the entire room ignites simultaneously.
Houses were literally blown off their foundations, entire exterior walls blown outward into the yard. The sheer volume of people attempting this DIY extraction led to a massive, undeniable spike in catastrophic structural fires. It fundamentally altered the demographic of local burn wards across the country.
Which perfectly explains a phenomenon the Nugnotes call the butane run. If every amateur in the country is suddenly doing this in their kitchen, the local supply chain for lighter fluid must have completely buckled. Where were they even getting all this butane?
They were cleaning out local smoke shops, hardware stores, and gas stations. Because wax culture was exploding in popularity, the demand for the solvent skyrocketed in tandem. We're talking about massive volume buying, master cases of butane being bought up, often driven by teenagers who had watched a Tokesity tutorial online and wanted to try it in their parents' garage.
It became such a visible, undeniable public safety hazard that local governments had to step in. Parts of California actually responded by legislating the sale of butane.
Right, they had to do something.
They capped the number of cans a single person could purchase in one transaction, and they required strict ID tracking for sales. They essentially started treating commercially available lighter fluid like a precursor chemical for illicit drugs.
And out of all this horrific wreckage, out of the burnt-out garages and the hospital visits, a grim but absolute survival rule finally cemented itself in the legacy culture. I remember reading this constantly in the forum archives.
Never blast where you sleep.
Yes, it became a rigid, unwritten law. Never blast where you sleep. It was a stark acknowledgement of the profound danger they were wrestling with. A warning passed around the exact same digital forums that had popularized the dangerous method in the first place.
So the sheer volume of these house explosions forced a massive reckoning.
Yeah.
The community had a clear choice: either adapt, evolve these crude methods to be safer, or face total destruction. And that destruction was either going to come from the explosions themselves or from the inevitable crushing crackdown by law enforcement who were tired of responding to blown-up neighborhoods.
Which brings us to a major turning point the Nug Notes refer to as the purge game. The community realized that relying on a hot car dashboard to evaporate the solvent was not only dangerous, it simply wasn't pulling the butane out of the dense molecular matrix of the shatter. They had to get significantly smarter about the physics of evaporation.
Right. They needed a way to pull the gas out without applying massive amounts of heat. Because if you just boil the extract on a stove, you destroy the terpenes.
Yeah.
The very flavor and aroma compounds you spent so much effort trying to extract in the first place.
Exactly. So the evolution shifted away from open air and heat towards something much more scientific, the vacuum oven. The vacuum oven became the accepted standard for safely removing residual solvent, and the mechanics behind it are a brilliant application of physics.
How exactly does the vacuum change the evaporation process?
It relies on the relationship between atmospheric pressure and boiling points. At sea level, the weight of the Earth's atmosphere is literally pushing down on liquids, keeping their molecules packed together. If you want a liquid to boil and turn into a gas, you usually have to add heat energy to agitate the molecules enough to break free of that atmospheric pressure.
But if you remove the atmospheric pressure,
Exactly. By placing the extracted concentrate into a sealed steel chamber and using a pump to pull a deep vacuum, you fundamentally change the physical environment. In a vacuum, there is no atmospheric pressure pushing down. Therefore, the boiling point of the liquid drops dramatically.
so the liquid butane trapped inside those microscopic bubbles in the amber can suddenly boil and vaporize at a much, much lower temperature.
Correct. The vacuum literally pulls the trapped butane gas out from inside the dense matrix of the wax at low, completely safe temperatures that preserve the delicate essential oils.
Oh, that makes so much sense.
Yeah, the extract expands like a muffin in the oven as the gas bubbles burst, and then it collapses into a completely purged, pure slab. The vacuum oven transformed hissing shatter and poop soup into clean, stable, chemically pure concentrates.
But that only solved the purging side of the equation. It made the final product safe to consume. They still had to address the actual extraction process, the open blasting of heavy gas that was blowing up the kitchens.
And that is where the shift from chaos to code really takes shape. The aftermath of all this wreckage birthed real engineering reform. We see the introduction of closed-loop systems.
I want to break down how a closed-loop system actually fixes the pooling gas problem, because it sounds like a massive leap from a PVC pipe.
It is a massive leap in thermodynamics. A closed-loop system is exactly what it sounds like. Instead of blasting butane through a pipe and letting the liquid fall into an open Pyrex dish, where the gas immediately boils off and escapes into the atmosphere or sinks to your kitchen floor, the entire process is hermetically sealed.
So how do you get the butane out of the extract if it is in a sealed metal tube?
By manipulating pressure and temperature, the butane washes over the plant material inside a pressurized sealed extraction column. The liquid mixture then falls into a sealed collection chamber at the bottom. Then, instead of venting the gas, they gently heat the collection chamber to turn the butane back into a vapor. But because the system is sealed, the vapor has nowhere to go.
Until they give it a place to go.
Right. They attach a recovery tank to the system and pack that tank in dry ice. The extreme cold creates a thermal vacuum.
Ah, clever.
Yeah. The warm butane vapor is violently pulled toward the freezing cold tank, where the extreme low temperature instantly recondenses the vapor back into liquid butane.
So the butane is completely recaptured. It cycles from a liquid to a gas and back to a liquid, all inside sealed steel. Nothing escapes into the air. Nothing pools on the floor.
Exactly. It is contained, it is highly efficient, and it completely neutralizes the risk of an environmental explosion. But this raises an important question. How does an underground, legally ambiguous, and often explicitly illegal community manage to develop rigorous safety codes and complex thermodynamic engineering standards?
It is pretty incredible. They didn't have government grants or university labs.
No, they didn't. It shows a community desperately trying to self-correct. They were actively working to save their own lives and legitimize their craft before regulators and the government completely stepped in to shut it all down. They were writing their own pressurized engineering standards out of sheer survival instinct.
So what does this all mean? When you think about it, the hyper-regulated, beautifully clean products you see on shelves today, the ones with the barcodes, the lab-tested purity stickers, and the child-proof, sleek branding, they are the direct, undeniable descendants of this incredibly chaotic, explosive history.
Without a doubt.
The sterile precision of today exists only because of the sheer recklessness of yesterday.
It is a legacy written in smoke, ruined kitchens, and wreckage, Open blasting absolutely birthed the modern concentrate industry. It proved the chemical concept worked, it built the massive consumer demand, and it drove the initial wave of innovation. But it left permanent physical scars on the culture.
And our source text, the Nug Notes, makes a very specific point to end on, which we want to echo here. They give a dedicated, sobering shout-out to those who got burned, who were scarred, and who lost everything in a matter of seconds from open blasting in their homes.
Yeah, that was a really powerful note.
It really was. They make it abundantly clear that looking back at this era is not meant to glorify the Wild West chapter of the industry. It is about remembering the extreme human cost of that innovation and paying respect to the people who carry those physical and emotional scars forever.
It serves as a stark reminder of the hidden human cost behind innovation. The dangerous, ugly trial and error phase is a part of history we almost always sanitize away once an industry goes legitimate.
And for you listening, it is really worth keeping this in mind the next time you see a perfectly packaged, rigorously tested everyday item. It's a reminder of the hidden trial and error that so often precedes the slick conveniences of modern life. The safety regulations and engineering codes we sometimes find tedious are almost always written in the aftermath of some very hard, very dangerous lessons.
They certainly are. And considering how this underground forum of self-taught chemists managed to invent industrial vacuum extraction standards out of sheer survival, it makes you wonder, what other massive multi-billion-dollar industrial innovations were actually born in someone's garage at 2 in the morning, completely off the grid, that we simply take for granted today?